In section 5.3, we talk about multiplying polynomials. This is so easy, you all. I only have six slides for this particular section. So when you multiply polynomials, basically you're multiplying terms. And if you have a monomial times a monomial, like in the examples that are shown here, it's very easy. You multiply their coefficients, and then you multiply their variables. And to multiply the variables, you use the rules that we learned in the previous section on how to multiply exponents. So let's look, and let's just jump on in here because it's really, really easy. 5y times 2y. Well, we say, well, what's 5 times 2? Well, that's 10. And y times y is y squared. Excuse me. So that's all you have there. Okay? Now, 5z to the third power times negative 4/10 z to the fifth. Well, we multiply the 5 times the negative 0.4. So I'm thinking that's probably a negative 2. And z to the third times z to the fifth is z to the what? We add them, so it's z to the eighth. So it's 5 times 0.4. Yeah, it is 2, negative 2. All right. Then we have fractional coefficients. The fractions are easy to multiply. Remember, when you multiply fractions, you multiply numerator times numerator, denominator times denominator. So we have a negative times a negative. That gives us a positive fraction that is going to be on our simplified expression. 1 times 7, and multiplying numerators gives me 7. 9 times 8, 72. And it's positive because a negative times a negative is a positive. But then we have b to the 6 plus 3, which is the 9. So remember, the b to the 9th can be in the numerator, but it cannot be in the denominator. Or you can write it 7 over 72 and write it next to the b to the 9th. But you have to be very careful that you don't write the b to the 9th in the denominator. And whatever you do, do not write your fractions like this. Slanted like that with a slanted line. Because I don't know what that means. I don't know if that means 7 over 72 with the b in a denominator, b in a numerator. I don't know what that means. So don't do that. I'm going to erase it. Always write your fractions with the fraction bar horizontal. Do not write slanted fraction bars. Okay, now we're going to multiply using a distributive property. So notice we have a monomial in the first example here times a binomial. Monomial is a one-term polynomial, and a binomial is a two-term. So what we're going to do is just distribute. We're going to say 8x times 7x to the fourth. 8 times 7 is 56. X times x to the fourth is x to the fifth. Then 8x times 1 is just 8x. So we've multiplied. Simple as that. Excuse me. Now we're going to multiply to distribute the negative 2x to the third power. Well, negative 2 times 3 is negative 6. X to the third times x squared is x to the fifth. All right, careful. Negative 2x to the third times negative x is going to be positive now 2x to the fourth. And negative 2x cubed times 2, positive 2, becomes negative 4x to the third. Negative 6x to the fifth, positive 2x to the fourth minus 4x to the third. Now, to multiply two binomials together, or two polynomials together, what you have to do is take one term in the first one and multiply it by all the terms in the second one. Then you go back and get the other term in the first one and multiply it by all the terms in the second. So in other words, every term in the first polynomial has to be multiplied by every term in the second one. And you can do this by using the distributive property with both of the terms. For instance, I'll say 4x times 3x and 4x times negative 4. And then we'll say 5 times 3x and 5 times negative 4. Okay? So everything's being multiplied. 4x times 3x gives us 12x squared. 4x times negative 4 is minus 16x. 5 times 3x is 15x. 5 times negative 4 is minus 20. Now, we have four terms, but if you would look at the two in the middle, they are like terms. So we can combine those. So we end up with 12x squared minus x minus 20. And from here, we can't simplify it anymore. We've combined all the terms, and there we have it. Now with this next one, be very, very careful. This is what we call a binomial squared. We are squaring a binomial. But what it means is 2x minus y times itself, 2x minus y. I'm messing up all of my variables here. 2x minus y times itself. Be very, very, very careful. This is not saying you can take 2x and just raise it to the second power, and the y and raise it to the second power. That is not what it's saying. Somebody's going to do that, and I'm going to be very, very upset, because this is not what it's saying. Anything raised to a power means that thing times itself that many times. So 2x minus y squared is a binomial that you have to multiply by itself. And it's a four-step process. Okay, you have to multiply all of the terms in the first binomial times all of the terms in the second one. And once again, we are going to distribute the 2x times 2x, 2x times negative y, the negative y times 2x, negative y times negative y. Okay, so we end up with what? 2x times 2x is 4x squared. 2x times negative y is negative 2xy. Okay, then we go to the negative y. Negative y times 2x is negative 2xy. Negative y times negative y is positive y squared. Once again, look at the two middle terms. They're like terms, so we can combine them. We have to combine them. But not only are they are like terms, they're exactly the same. So we combine them. Negative 2xy and another negative 2xy gives you what? Not 0. It gives you a negative 4xy. Okay? So we have 4x squared minus 4xy plus y squared. Be very, very careful when squaring a binomial. Now we have a binomial times a trinomial. So what do you think we're going to do? We're going to multiply x times everything in the second one, in the trinomial, and then 3 times everything in the trinomial. Okay? Let's talk it out. X times 2x squared is what? 2x to the third x times negative 5x is negative 5x squared x times 4 is 4x. Then we have 3. 3 times 2x squared is 6x squared. 3 times negative 5x is minus 15x. 3 times 4 is plus 12. Now we have to see what we can combine. Okay, so we only have one x cubed term, so 2x cubed remains the same. The x squared and the x squared here can be combined. So negative 5x squared plus 6x squared is plus x squared. Then we have some x terms. 4x and a minus 15x becomes minus what? 11x. And then we have one constant plus 12. There's nothing else to add. I made a 2, but it's plus 12. There's nothing else that we can combine. And notice how we wrote it. We have it in descending order. I want you to get into the habit of writing these in descending order. Okay, here's another one. I'm just going to go for it. You all follow along. So we have y times 2y squared gives me 2y to the third. Y times negative 3y is negative 3y squared. Y times 5 is plus 5y. Okay, now 4 times 2y squared is 8y squared. 4 times negative 3y is negative 12y. 4 times 5 is plus 20. We should have 6 terms because we multiplied y times 3 terms and then 4 times 3 terms. That gives us 6 terms, and then we combine what we can. 2y cubed doesn't combine with anything else. Negative 3y squared and 8y squared gives us plus 5y squared. Then I have 5y minus 12y gives us negative 7y. And one constant is 20. And that's our simplified form. We have just multiplied the polynomials. Now, if you're given a polynomial to multiply times another polynomial, you can also set it up vertically, kind of like we do with regular multiplication if we multiply two numbers. But watch how I'm going to take the problem as given to me and rewrite it. One right underneath the other one. The thing is, you don't have to line them up according to like terms here to multiply, but you do want to, after you go through the multiplication process, you do want to line them up according to like terms. And just watch what I'm talking about. So we're multiplying. You take the 1 and multiply it times 5. Then multiply the 1 times negative 4y. Then multiply the 1 times y. You're doing the same thing, you're just doing it vertically now. Okay, 1 times 5 is 5. 1 times negative 4y is negative 4y. And that 5 is positive. Positive 1 times y squared is y squared. Now watch what I do when I move over to the 3y. I have 3y times 5. That's going to give me 15y. Notice I'm multiplying the 3y now times the 5 times the negative 4y and times the y squared. 1 by 1. So 3y times 5 is plus 15y. And notice I'm writing it underneath the other y's. So when I add them up, they're going to be all lined up together, and I can combine my like terms. 3y now times negative 4y. That gives me a negative 12y squared. Okay, then 3y times y squared gives me 3y cubed. Well, there's no cubes to line it up with, so all I have to do is add them up and down like we normally do with multiplication, and finally we're going to add. So we get 5. Negative 4y and 15y is what? 11y. Y squared minus 12y squared is negative 11y squared. And then we bring down the 3y squared. I'm sorry, 3y cubed. Okay? And everything is in descending order. So what we did here was we combined our like terms in kind of like one step. We didn't have to do that as our last step. Okay? Vertically, I don't care which way you do it. You can do them spread out like this, or you can do them vertically. I don't care. You're going to get the same answer. Whichever one you see is the easiest. So I'm going to do this one vertically. 5x squared minus 3x plus 5 times x minus 4. I'm going vertically. Okay, negative 4 times 5 is negative 20. Negative 4 times negative 3x is plus 12x. Negative 4 times 5x squared is negative 20x squared. Then x times 5 is a positive 5x. X times negative 3x is negative 3x squared. Then x times 5 is, x times 5x squared is 5x to the third. And check my signs, make sure my signs are right. This is going to be a negative 20, a positive 12x, a negative 20x squared. Then I should have a positive 5x, a negative 3x squared, and a positive 5x cubed. All right. So now I add 20, negative 20 comes down, 12 and 5 is 17x, negative 23x squared, and 5x to the third. All right, so this gives us an answer that's already combined the like terms. Okay, this is very, very easy, but if you understand multiplying, you have to understand the multiplying before we could ever get to the dividing of these polynomials. Good luck.